Welcome to Module 3, Pandas, your data manipulation powerhouse. This module will help you master the essential Python library for transforming messy, real-world data into clean, analysis-ready datasets for machine learning and data science. This course is brought to you by the Series of Thoughts tech team. Pandas is critical because real-world data is inherently messy, incomplete, inconsistent, and unstructured. As the industry standard tool, Pandas acts as the bridge between raw data and actionable insights, letting you clean and transform data before any machine learning model is applied. In this module, we will cover 6 key areas: DataFrames and Series, reading and writing data, data exploration, selection and filtering, data cleaning, and transformation. These steps form the core of effective data preparation. The heart of Pandas is the data frame. It is a two-dimensional labeled data structure, much like a spreadsheet or SQL table. It allows you to work with structured data, where columns can contain different types of data, and rows represent individual records. You can create a data frame from scratch, often using a dictionary. Here, each key becomes a column name, and the list values become the column data. This creates a powerful structure ready for manipulation. In contrast, a series is a one-dimensional labeled array. Think of it as a single column from a data frame. Series are useful for working with a single variable and allow for easy access and manipulation of individual values using an index. Use data frames when you need to analyze complete datasets, work with multiple related columns, or read data from files. Use a series when you are focusing on a single column of data or extracting a feature for specific analysis. Pandas concepts are familiar if you've worked with spreadsheets or SQL tables. Like SQL, you can filter and group data. Underneath, Pandas uses NumPy for fast numerical computations, adding labels and mixed data types to its power. Pandas makes reading data simple, with specific functions for CSV, Excel, and JSON files. You can also specify options like setting a header row, choosing an index column, or only reading specific columns. Saving your processed results is just as easy using 2 methods like backquote to underscore CSV backquote to underscore Excel backquote, or backquote to underscore JSON backquote. Remember to use backquote index equals false backquote to prevent writing row numbers to the file, which is often unnecessary. For files too large for memory, use chunking to read and process data in smaller batches. This prevents crashes and is essential for big data projects. You can also use the backquote nrows backquote parameter to read only a specific number of rows. Before diving into analysis, you must explore and understand your data. Essential data exploration methods provide a quick overview of your dataset structure, content, and quality. Commands like backquote head backquote tail backquote info backquote, and backquote describe backquote are your first steps with any new dataset. They reveal the structure, size, column types, and statistical summary, helping you plan your cleaning strategy. Always check for data quality issues. Use backquote isNull.sum, backquote to find missing values, backquote duplicated.sum, backquote to count duplicate rows, and backquote unique, backquote to understand distinct values in a column. Understanding data types is vital for machine learning. Numerical types are used directly, categorical types need encoding, and datetime types allow you to extract features like day or month for analysis. Column selection is fundamental. Use single brackets to select one column, which returns a series. Use double brackets to select multiple columns, which returns a data frame. You can also use backquote drop backquote with backquote axis equals 1 backquote to remove specific columns. When selecting rows, you have 2 primary methods: backquote lock backquote and backquote ilock backquote. Use backquote lock backquote for label or index name-based selection. Use backquote ilock backquote for integer position-based selection. Note that backquote lock backquote is inclusive of the endpoint, while backquote ilock backquote is exclusive. Boolean indexing is powerful for filtering data based on conditions. You can use simple filters or combine multiple conditions using the ampersand for and the pipe for or. The backquote ISIN backquote method is helpful for selecting multiple specific values. When performing Boolean indexing, always wrap each condition in parentheses when using backquote and backquote or backquote operators. Never use the keywords and or. For complex filters, break them into smaller, readable steps. Handling missing values is crucial as it directly impacts ML model performance. Missing values are inevitable, so choosing the right strategy, dropping or filling, is key. You can remove rows with missing data using "drop" or fill them using "fill". You can fill with a constant, a column's mean, or use methods like forward or backward filling. Drop missing data when the percentage is small or the dataset is large enough. Fill missing data when the percentage is high, the dataset is small, or you can reasonably infer the missing values. Always address them before modeling. Beyond missing data, clean your data by removing duplicates using "drop_duplicates", converting column types using "astype", or to "datetime", and renaming columns for clarity using "rename". Feature engineering is essential for improving model performance. You can create new features through simple calculations, or by using the "apply" method with custom Python functions to categorize or transform data. Grouping and aggregation allow you to compute statistics across different segments of your data. Use "group by" to split data based on a column, and then apply aggregation functions like "mean", "min", or "max". Sorting your data helps in identifying outliers and trends. Use "sort_values" for columns and "sort_index" for rows. You can also create a numerical order using the "rank" method. For text data, Pandas provides the ".str" accessor for common string operations like converting case, calculating length, splitting strings, or performing pattern matching using "contains" or "replace". Putting it all together, a typical machine learning pre-processing pipeline involves 5 steps: load and inspect, handle missing values, remove duplicates, create new features, and finally, prepare the data for the ML model. This code demonstrates the full pre-processing flow, from loading data and filling missing age values with the median, to removing duplicates, engineering a new "age_group" feature, and ultimately splitting the data into features, X, and the target, Y. Data quality has a profound impact on machine learning. Data scientists spend about 80% of their time on data preparation. Proper cleaning can improve model accuracy significantly and lead to faster training. To practice your Pandas skills, we have provided a customer-churned dataset. It contains realistic data quality issues. Apply the complete pre-processing pipeline to clean the data and prepare it for a machine learning model. To avoid common Pandas pitfalls, always use "in place equals true", or reassign the data frame after operations. Avoid chained indexing and use "lock" instead. When working with large data, be mindful of memory usage. The key takeaways are: data frames are your primary tool. Always explore data before analysis. Data quality determines model quality, and feature engineering creates the most value. Your learning path includes practicing with real datasets, building reusable cleaning pipelines, combining Pandas with other tools like NumPy and Matplotlib, and continuously referencing the extensive Pandas documentation. Next up, we transition from clean data to clear insights with data visualization. You will learn how to use plotting libraries to create compelling visualizations that reveal patterns and effectively tell your data's story.